point of the triangle.
Okay, we're trying to find minimum, maximum rates of change, right?
All you do is just plug it in and go through the steps.
Okay, now, how do we represent a rate of change?
Change
What
is
is
y
it?
over change.
Which is a slope, right?
Yeah. So
Okay, so that would be minimum and maximum slope. Okay, now we got an estimate, we got a 1.8, right? Okay, where do you find the maximum slope in this graph?
It's the maximum
wherever
slope.
it's
It's the circle?
no.
Infinity.
Yeah, well, and I wasn't real, yeah, the slope does approach infinity, right?
Uh-huh.
It keeps getting steeper. Now, I should have said the minimum graph, minimum maximum on the graph as shown, you know, just the part of the picture that we see, right?
Yeah.
And I didn't specify that, so make a note that that's really what we're talking about, right? Although if you want to say, you know, maximum's going to be infinity. It's going to approach infinity. There's no maximum. Because infinity is not any fixed number, right? Just keeps getting big. Infinity means it gets bigger and bigger. Okay? So, where on this picture, I'm going to trace this graph from left to right. And you're going to tell me where you think you see the maximum slope. Are you ready? Now, everybody close their eyes and watch me do this. No, you
Wait.
can't do that.
I got it.
Okay,
Abby's got this.
okay, but tell me when you think you see the maximum slope.
Right there.
Here?
Yep.
Like, keep going a little bit.
I gotta keep going? Backwards or forwards?
Forward.
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 Because it'd be like the farther you go.
Oh, okay,
Yes. About right there. Like,
Okay, well, the slope keeps getting bigger,
exactly.
so the maximum slope's probably gonna occur here, right?
Yeah.
Make sense?
Yes.
Okay,
Yes.
make sense?
Yes.
Now, that means you take this last point on the graph, and listen to this carefully. Now, you take the last point on the graph. Now, I could draw a slope between this point and this point, right?
Yeah.
But I could draw a steeper slope, like between this point and this point, right? And of course, the way this thing's curving, the closer I get to this point, the steeper it's going to be, right?
Yes.
So I want to take the closest possible point and draw a slope. Okay? So I'll draw myself a little fundamental triangle here. And I'll draw this line. I want to draw a big line because I'm going to estimate a couple of coordinates and calculate. I'm going to just do a fundamental triangle, and I don't want to do a tiny fundamental triangle. You know, go ahead and estimate accurately the coordinates at the corners of this triangle here. Okay? You're not going to make a very accurate estimate of the slope. But on this triangle, let's say this one here, I can make a pretty good estimate of the slope, can't I? Understand what I'm doing? Okay? So, we do a tiny fundamental triangle. We extend the hypotenuse. Form a big fundamental triangle and estimate the slope. Okay? What do you estimate the run to be here? More than one or less than one?
More.
More than two or less than two?
Less.
Okay, clearly not two. It's this far, and one is this far. So it looks like 1.3, 1.4.
1.5.
Okay, be that way. Run 1.5. I'll accept anything I hear as long as it's reasonable. That's reasonable. Run 1.5. What's the rise look like?
Um,
About
it's about 4.
4?
3.
Okay, I heard a
I think
reasonable
3
number.
would be a
First
little
reasonable number I hear I'm gonna use.
Because it's like a scale of 2.
Okay? Maybe a little less than 4, but 4 is probably closer than 3, right? And you don't want to go, you know, 3, yeah, it's really 3.78942. Everybody
Yeah,
should see
exactly.
Okay. So we estimate rise 4 and run 1.5. Four is 4 over 1.5, that's about 2.7. And that's our estimated maximum slope. Okay? What about minimum slope?
They'd probably be
Minimum
close to the
slope will go
origin.
from
Again?
0 to like 1.8. Where that
Okay, well, actually get the minimum slope, it's gonna be a negative,
Oh, okay.
right? Because a negative number is less than
So you just
positive.
mirror it on
So
the other
actually, you're
side?
gonna probably say, well, minimum slope's gonna be over here. So I do a little tiny triangle. How am I gonna do
Wouldn't it
that?
just be the
Okay.
negative
And then I
version?
Yeah.
extend this, and I do this, right?
Uh-huh.
Now, in the case of this graph,
It'd just be the negative.
it's symmetric.
Yeah.
That's
The way I drew it, it isn't all that symmetric, so my estimate here is gonna be quite a bit different, but that's just because I can't draw a good parabola. Okay?
Yeah.
So the minimum slope looks like a run of
So it's
0.7. And the rise looks like it's about -4. So minimum slope, approximately -4 over 0.7, approximately equals -6.
It's technically not a parabola.
6.
I'll note that the actual picture is symmetric. So the minimum slope will probably be the negative of the maximum slope, but that won't necessarily always be the thing, okay? Just trying to get you used to looking at properties of graphs, right? And also to understanding slopes a little better, because I'm right on the verge of the first thing you do in calculus here, okay? The first thing you do in calculus is you say, well, I don't take just a little tiny fundamental triangle. I take the tiniest possible fundamental triangle, meaning I take a limit as the size of this triangle approaches 0, and I get the actual maximum slope. For an estimate, a tiny triangle is going to be just fine. Okay? So we understand we don't want to use a triangle from here to here. That's not going to be the maximum slope, or from here to here. We use the tiniest triangle we can find, and then we go from there.